In this problem, we have a horizontal spring with a constant of 300 newtons per meter with a 5 kilogram mass attached that is pulled back 10 centimeters. So there's a lot of information provided in that sentence. First is the spring constant, which is the 300 newtons per meter, and the mass of the mass attached, which is the 5 kilograms. So we're taking this spring, and we have it laid horizontally, and there's a mass attached. And then we're going to pull it back 10 centimeters and let it go so that it then oscillates back and forth. So that 10 centimeters is going to be the amplitude of the oscillation, because that's setting how much spring potential energy is in the system. And that spring potential energy is going to oscillate between kinetic to back to spring potential energy, back to kinetic, back to spring potential energy. So that 10 centimeters is setting how much energy is in the system by setting how far the spring back is maximum and how much spring potential energy there is in the system initially. Alright, so we then in part A want to know what the maximum velocity of the oscillation is. So what's the maximum velocity? What is the maximum acceleration? And what is the total energy of the system? So the maximum velocity is going to occur when all of the energy is kinetic energy. So all of the energy is kinetic energy when none of it's potential energy, so when x equals 0. So I'm going to take my equation, velocity equals the square root of k over m times the quantity a squared minus x squared. And I'm going to plug in 300 newton meters for the spring constant, 5 kilograms for the mass, and a is going to be the 0.1 meters, so because that's constant for that particular situation. And then 0 for x. And so that's going to give me a velocity of 0.775 meters per second. Now we want to know what the maximum acceleration is. Now the maximum acceleration occurs at the other extreme of our oscillation. So that's going to occur when x is the greatest. So we know acceleration equals kx over m because the only forces we're worried about here is the spring force. So we're going to take our 300 newtons per meter times the 0.1 meters divided by the 5 kilograms, which is 6 meters per second squared. So notice that we are plugging in two different x values between a and b, because the maximum acceleration does not occur at the same point in the motion as the maximum velocity. In part C, we want to know what the total energy of the system is. And we have two options here. We're going to either deal with the maximum spring potential energy or the maximum kinetic energy. Either option will get you the same answer. I chose, when I wrote this up, in order to use the maximum spring potential energy. So that would be when the energy is equal to 1/2 k times a squared rather than x squared, because that's x is maximum when it's equal to a. So we're going to take 1/2 times 300 newtons per meter times 0.1 meters squared, and that gives us 1.5 joules.